I think there is something paradoxical about positing the existence of infinity. There have been a lot of thought experiments used to suggest this to be the case, such as Hilbert's Hotel, the Grim Reaper paradox, Smulyan's rod, and others. But I'll share just one with you that I like, an infinite card game. Imagine a deck with an actually infinite number of cards. Imagine that on each card is a positive integer, from 1, 2, 3, ad infinitum. There is a card with each and every positive integer on it. And we're going to play a game with the deck. But first, we have to have the cards shuffled. How would you shuffle an infinite deck? Well, in this thought experiment, we are positing an actual infinity exists, or can exist. So we could simply say that for every n days ago, we shuffled the top n cards in the deck. 10 days ago, the top 10 cards were shuffled. So that would mean all the cards in the infinite set get shuffled. Okay, that works, I guess, at least for the purposes of the thought experiment. So what's the game? For the game, you and I each pick a card from the deck. Whoever's card has the higher number on it will win $100. Seems simple enough. But now imagine picking your card and taking a look at what number you have before we show each other our cards. You're going to see it and instantly be certain that you've lost the game. How can you say that? Well, let's just imagine your card is 10,000,000,007. How many cards are going to have lower numbers in the entire deck? Well, 10,000,006,000. One card for each whole number between 1 and my card's value. You're right. And how many cards are going to have higher numbers than yours in the deck? I suppose it would have to be an infinite amount of cards, right? Correct. No matter what number is on your card, even a Google, there will always be a finite number of cards with lower values and an infinite number of cards with higher values. But wait, that would also be true of your card, wouldn't it? Precisely. We would both be in the same boat, and so both of us would take a look at our finitely numbered card and would be more than 99.99% certain that the other person had a higher number on their card. But that doesn't make sense. Two cards in a well-shuffled deck would obviously have a 50-50 chance of being higher or lower than the other. And that's where the contradiction appears to come in. An actual infinite seems to break the laws of logic in this case. On one hand, the odds to win should be 50-50, but from our individual perspectives and the cards we each have, it looks like winning is all but impossible. Wow, yeah, I see how the logic seems to bend when we use an actual infinity. And this is just one example. As I said, there are many others. Because of these absurdities that seem to arise when we talk about actual infinity, I think it is very reasonable to adopt the view that an actual infinity cannot exist in time and space.